My name's Alicia Culver. I'm the director of the Responsible Purchasing Network, and I have been working on lighting now for about 8 years, mostly under EPA grants, to figure out how do we optimize all the different aspects of lighting, energy efficiency, lamp life, and reduce maintenance, as well as toxicity, and then dealing with the end of life. So we're going to talk a little bit about some of the work that RPN has been doing. We have 2 different lighting purchasing guides that we've developed, one on fluorescent lighting and one on LEDs, and I was the author of both of those. And so I'll be drawing from some of the research, looking at what are the best practices, what are some policies related to those products, specifications, case studies. So what we try to do is we learn by working with individual jurisdictions or by researching the field as a whole, put the information into a guide, and develop that information for our membership. So why purchase green lighting? Lighting is actually low-hanging fruit when it comes to energy efficiency. It's one of the most cost-effective ways of reducing energy in your facilities. You also get greenhouse gas reductions, you can get mercury reductions, other environmental health benefits, and you can save money by lowering utility bills. And you can also earn green building credits through the U.S. Green Building Council by updating your lighting. So in terms of lighting, there are different opportunities to purchase lighting, and I wanted to just break them down into the different types of contracts. One is commodity contracts, so you might be buying just the lighting equipment itself, either lamps, ballasts, or fixtures. You may be buying commodity contracts off of office supplies contracts or hardware supplies contracts or electrical supplies contracts, and there also can be lighting embedded into a certain type of equipment, maybe some furniture that has lighting equipment on it. So all of those are places where lighting comes in. There also are service agreements for lighting, either for your lighting retrofit projects that you're doing, in new construction, renovation, relamping projects. All of those are places where the lighting specifications would be included in those types of contracts. So when looking at lighting, as I mentioned earlier, we want to optimize the various different aspects of lighting. So typically we want to look at energy efficiency, which is the most important from many perspectives, but also lamp life. When we've had the different end user groups, like Chris Geiger talked about from San Francisco at the earlier session, the way that they have pulled together the custodial supervisors, they also, within their city, have pulled together the electricians, and we've met with the electricians and different people who are working on lighting to develop specifications that they're using. Actually, San Francisco is in the process of being out to bid on some comprehensive environmental specifications for lighting equipment, which I was the technical lead on. And so we've been looking at how do we break down the different types of lighting equipment and improve the energy efficiency, the lamp life from the custodial and maintenance staff's perspective. The lamp life is actually the most important because it really impacts their jobs, the number of times they have to reorder the equipment, install it, and then dispose of it at the end of its life. And the cost of actually disposal at this point is really high. It can be as high to, for example, recycle a compact fluorescent as it can be to purchase it in the first place. And actually, we're going to be joined by Donna Sneerger at the end of the session, who is with the California Product Stewardship Council, and she's going to talk about some of the end-of-life issues associated with lamp recycling. So we also want to look at the toxicity. Lamps can have lead and mercury, ballasts can have PCBs and lead, and then we want to make sure that there's recycling and that it's convenient, and if possible, private sector finance. We want the companies that are manufacturing and selling these products to be participating in developing a recycling system, and that's starting to happen, certainly happening in Europe and starting to happen in the United States. And increasingly, people are thinking about how is the lighting equipment manufactured? A lot of it is manufactured in China, particularly the fluorescent technologies and some of the LED technologies. We want to make sure that it is manufactured in a way that isn't poisoning the workers and the environment surrounding those manufacturing plants. So that's a lot to be thinking of when you're thinking about lighting, but I'm going to show you how to put that all together. So the first aspect of lighting is energy efficiency, and that can apply to lamps, ballasts, and fixtures. And we want to make sure that high-performance lighting equipment is purchased because it has an impact certainly on the environment as well as on the cost associated with running those products. So some of the specifications that you can use for T8s now, T8s are tubular fluorescence. Actually, let me get a sense. Are people familiar with T8s, or do I need to go through at that level? Everyone okay with that? So tubular fluorescent, it's a more modern fluorescent 1-inch diameter. And ballast, the high efficiency models of those can have a certification by the National Electrical Manufacturers Association, and it'll be called NEMA Premium Efficiency, and they're lighting organizations that have lists of those NEMA Premium Efficiency lamps and ballasts that are available. They're sometimes called Super T8s, and if you're looking for them, you can find them with certain codes in the lamp code. One would be SPX or XP for extended performance, or the Advantage line. So all of these are when you're looking at a piece of fluorescent lighting equipment, there's different grades. There's usually a standard efficiency, then there's a high efficiency, and sometimes there's even a super high efficiency. Yes?
So do I interpret that to mean that the super T8s are higher efficacy?
Yes, they're higher efficacy. So, for example, if you have a 32-watt T8, which is your typical 4-foot T8, there are some that put out 2,800 lumens, some that put 3,000 lumens, some that put 31 or 3150 lumens for the same 32 watts. And so one of the ways in which you can increase the efficacy, and I actually worked on a lighting retrofit with someone from Lighting Wizards who's out of Walnut Creek and one of the top lighting people in the country. We did a lighting retrofit for Alameda County. They went from typical standard efficiency lamps and ballasts that already were in the T8s. They had already gone from T12s to T8s, and they did another retrofit, cost-effective retrofit, from the standard efficiency to using these super efficient, and they were able in many cases to have, they had fixtures originally that had 3 lamps in them. They were able to get them down often to 2 lamps, sometimes even to 1 lamp, because in some cases they also found that it was overlighting. Yes?
This was just by replacing lamps, or did they do ballast as well?
Did the ballast as well.
Okay.
So they found that the ballast had been in there for about 15 years, so they went to high efficiency. So same thing, you can have NEMA Premium Efficiency ballasts as well, and they have a higher efficacy level. So if you pair those two together, you can end up with a system that is much more efficient than a typical system that I see in a state and local government office. On certain types of fixtures, you can use specify Energy Star as the high efficiency fixture, or if you're looking, another way to find the higher level fluorescence is to use what's called the color rendering index, the CRI. Some of the utilities use this. So the Super T8s tend to have a color rendering index of 85 or higher. And so anything that's under 80 is going to be a lower efficiency lighting. And in fact, the Department of Energy is starting to phase those out of production in the United States as well. So you can also be very proactive about eliminating inefficient types of equipment from your facilities or from your contracts. So in San Francisco, they have eliminated standard incandescent lighting, the older fluorescents that are T12, or you can see the round. That's called a T9 fluorescent, circa my grandmother's house in the 1960s. Those are, you can usually also tell them because their color is really horrible. They usually make your skin look really pasty. Often they'll be used with an older ballast system that is takes time. It's called a rapid start, but it actually is not rapid start. It's kind of a slower start instead of an instant start, so it takes time to flick it on. Also, the older technology is called preheat fluorescent lamps. You'll sometimes see them under cabinets, and they're usually smaller. Mercury vapor lamps, first generation of high-intensity discharge lamps, all of those are just everything in that category is inefficient. So San Francisco is just saying you can't sell those types of products on their contracts. And they also have banned magnetic fluorescent ballasts as well as mercury vapor ballasts from their contract. Because once you get a ballast in, you're stuck with that type of technology. So sometimes people will say, well, I have an old ballast, I just want to replace the lamp. So you keep replacing the lamp over and over again. But once the ballast or the fixture goes, that's your opportunity to really leapfrog over into the next generation of efficient technology. So I wanted to just show you how you could find some of these in a catalog. So this is actually from a General Electric catalog, and you'll see the initial lumens. This is a 25-watt lamp, and you'll see this lamp has 2,080 initial lumens. Initial lumens are what the lamp starts out with. Lamps always fade, so you'll see the mean lumens. That's what it kind of fades into about halfway through its life. This same 25 lamp, this is the higher efficiency one, will put out 2150 lumens, and then sometimes there's even on top of that. So in order to bring about these different types of more efficient and environmentally preferable lighting products, some jurisdictions will adopt a lighting policy. And this is an example from New York City. They actually adopted an energy efficiency law that had a big section in it on lighting, and they set minimum efficiency levels and maximum mercury levels for all lamps purchased by city departments, and they maintain a listing of what the mercury and the efficiency levels will be for different types of lighting. And they specifically were the first large city to ban standard incandescent lighting from all of their operations whenever a practical alternative was available. So when I was working with them on this project, we literally printed out a list of every single light bulb that they purchased and looked, is there a compact fluorescent that could replace that? Is it the same size? Will it fit in? And now they're starting to go through that with the LEDs as well. So that's the efficiency side. In addition to the efficiency of the lamp, you want to look at the lamp life. In the same way that there are different grades of fluorescent lights with respect to their efficiency, there are different grades with respect to the lamp life of the equipment. And so you want to specify long-lasting lamps because that reduces the number of times that it has to be replaced. And this can be particularly important if it's someplace that's very difficult to get into. So I said a high bay application like a gymnasium or something that's very difficult to get into sort of logistically. You want to specify lamp life minimums based on rated hours and eliminate certain types of lamps that have an inherently short life. So that would, and luckily it's the same ones that often have the low efficiency as well. So there's not a trade-off between lamp life and efficiency. So the same way, incandescents, very short lamp life, about 700 hours to 1,500 hours, whereas you can find replacement lamps. I did actually bring a couple with me. Let's see. This one can replace an incandescent candle, 12,000 hours. A typical candle lamp might last 1,000 hours. Some of these other ones, here's an LED, for example. Instead of 45 watts, it uses 8 watts, and it lasts up to 30,000 hours. So you can really see that, putting one of these in can replace lots of different lamps, so it justifies the higher upfront costs. So you want to also look for lamps you can either specify a certain minimum rated life, and that can be by different category, because you're going to have a range. We'll do the same table maybe for the rated life. So a compact fluorescent usually is rated between 6,000 hours and 15,000 hours, but an LED usually starts at around 10,000 hours and can go up to 35,000 hours. So you can see that they have just a much longer life. But within just even the fluorescents, you can look for ones that are designated as long life, and they usually have an XL, or that's a GE, or an XP for Sylvania, or Plus for Philips. Sometimes they'll even have extra long life, or SXL, super extra long life. So you want to look for those long life lamps. And then there's certain other types of lamps that typically, again, have a long life, like the LEDs, but also cold cathode CFLs typically last longer than a regular CFL, compact fluorescent lamp, and then induction lamps and LEDs. And so that just shows you, here are some places where it's difficult to get to, particularly street lighting. You want those to be lasting a long time. You don't want it to be going out and creating a safety problem. And you can see how one LED can replace dozens of incandescent light bulbs. So the same way, here's the GE catalog, and you can see these are the 4-foot T8 Ecolux up in the left-hand corner, and a typical one will be rated at 30,000 hours. Okay, but then we have also the extra, the XL ones that are the extra life. Those same, but they're rated at 36,000, and then they have the super long life, which is rated at 40,000 hours. So you're paying a little bit more, but you're not having to replace that lamp as often. I just thought this was interesting. I did some work in Europe looking at the mercury standards and helping to set some international mercury standards for lighting, and I found out about a lamp that was designed by Osram Sylvania for Germany, and it lasts 90,000 hours. Now, if we had a lamp that lasted 4 times as long, we would be saving a lot of money in avoiding lamp costs. So I'm working with some states to try to see if we can get this lamp tested in the United States. The next issue is toxicity, the big issue with fluorescent lighting. Mercury is a big issue. There's mercury in every type of fluorescent lamp, whether it's a linear or circular or compact fluorescent lamp. Also, high-intensity discharge lamps, obviously mercury vapor, but the street lighting that is typically high-pressure sodium or metal halide. There's also a lot of mercury in neon signs, which still are using old dosing methods with like a dropper. So all of these types of lamps have mercury. There's no mercury in LEDs, by the way. Mercury is used, it's added to form a vapor, which produces light when the current is passed through it. All fluorescent lights contain some mercury. So what our strategy has been is to work to figure out what is the least amount of mercury that we need to not have a trade-off with efficiency or lamp life. And that is debated widely throughout the United States and throughout the world. So mercury is a problem because it can get released anywhere along a lamp's life cycle when it's manufactured, especially if older dosing methods are used, when it's transported. So if a lamp breaks, I was just actually visiting my parents, and they were taking one of the compact fluorescents to the to be recycled, and the seat got pushed back and the lamp crushed in the car. So it just can happen during installation or storage, especially if you have an 8-foot fluorescent or a U-shaped one. They can snap easier. They can break often in the dumpsters or in the garbage trucks, and then when they rinse out the garbage trucks, you can end up having mercury going into the water supply. Mercury can also get released even during the recycling if you're not careful, if lamps are crushed, or if they, during the recovery process, some of that mercury can get released. So given that we have very high levels of mercury in fish, we want to make sure that as much as possible we're reducing the mercury in the lamps. So here's how you do that. You can require mercury content and lead disclosure. There also can be lead in a lamp. It usually is found on the bottom. there's a little bit of solder here, and there may be some solder around. Newer lamps are going lead-free largely because of requirements in the European Union. And the requirements are called the Restriction of Hazardous Substances. All electrical equipment in the EU, the European Union, cannot be sold if it contains lead or mercury or other hazardous materials unless they have a specific exemption where they show we need that lead for some reason, or we need a certain amount of mercury for some reason. So the debate has been on fluorescent lamps, how much mercury is needed, and that's the process that I've been involved with on an international level. So you can set, and the RoHS does this, it sets mercury limits by lamp type. And the RoHS is actually of particular interest to the United States because California adopted a law that says whatever is the mercury limits and lead limits that are set in Europe are going to be adopted in California. And so we have been working hard to make sure that those get implemented. You can also prohibit certain types, again, certain types of lamps inherently have more mercury than others. Mercury vapor, for example, has a lot of mercury. Standard metal halides, some of the older preheat and older fluorescent lamps used more dangerous and inefficient dosing methods. And so when you get rid of those lamps for efficiency reasons, you're also getting rid of the lamps that have a lot more mercury in them. So the modern compact fluorescents and high efficiency T8s have much less mercury than the older fluorescents. So we're really trying to get them out for all of those reasons. And so you can apply, again, looking at the fixture level, just say, we're not going to allow any fixtures that use mercury vapor. Then you're taking them off your contracts and you're making sure that those technologies don't go in. There's some entities that are getting involved. I work with Walmart to try to get a requirement that safer dosing methods are used so that the workers are protected when they manufacture compact fluorescents as well. Most specifications don't get into that level. But I will say to get to the lower mercury levels that are required under the RoHS, you can't use the less safe dosing method. So we're protecting workers at the same time. You get credits for putting in low mercury lighting. And so the intent of it is to reduce the amount of mercury brought into the building or onto the building site through the purchase of lamps. You'll get 1 LEED point if the mercury content of the lamps is below 90 picograms per lumen hour. This is a complicated calculation. It's not my preference of the way that it does it, but they did that to be able to allow more mercury to go into lamps that have a longer life or are brighter. And to make it easier, there's been a lot of pressure put on the 3 major manufacturers to report what the picogram per lumen hour is, so there are these calculators online. This is Sylvania's calculator, a little bit more challenging to use, but also relatively transparent. So you put in the lamp model number, and it will tell you what the lamp code is, and then it'll tell you what the mercury content is in milligrams, and then calculates ultimately the picograms per lumen hour of all the lamps. So that you don't have to do it by hand. And then this is GE's calculator. It does the calculation for you, but is not transparent. You can't tell how much is in the mercury in the lamp. You can back calculate it if you have some of the other information, but you probably wouldn't want to do it. This is the law, the Lighting Efficiency and Toxics Reduction Act that was passed in 2007, which adopts the first RoHS standards, and those applied originally to just compact fluorescents and linear fluorescents. But on 2012, the new RoHS standards went into effect in Europe, and we're still arguing with the industry about whether the law is going to allow those to go into effect. But there should be new, more stringent mercury standards and lead standards going into effect for all lighting equipment sold in California. So here's how you put it all together. You have model bid specifications that will address the efficiency of the lamps, the rated life, the toxicity, so you can reference RoHS compliant, and then also add on the recycling piece of that. And if anyone is going out to bid for lighting equipment, I'm happy to share with you the specifications that we developed for the city of San Francisco. They're comprehensive, probably about 10 pages long, looking at every single type of lamp and looking at the efficiency, lamp life, and mercury levels for each of those categories of lamps. They prohibit the red flag products like the old fluorescents and the mercury vapor lamps and the incandescents and certain types of ballasts. And they work really hard to try to negotiate good prices on the more efficient lamps. LEDs have always been an add-on, and so often you'll get these great discounts on incandescent light bulbs or old, T12 light bulbs, old fluorescent light bulbs, and then you'll just get a tiny, minuscule discount off of the LEDs or the high-efficiency stuff. So we have been working hard to try to figure out how do we design the bid specification and bid evaluation criteria to really encourage the vendors to give us better discounts on LEDs. And it may be that just going out to bid separately for LEDs is one way to do that, or having a bid evaluation criteria where you're giving more weight to the discounts that are given on the environmentally preferable lighting equipment. So there's all of these issues. There's a lot that you can go into in more detail, but I'll say that's the major thing that we've been trying to do with some success. This is a sample of a lighting contract for California, and you'll just see how it works. So they actually decided to go in for each individual type of lamp with the different colors and everything. They set a mercury limit. They set a rated life minimum, and they set a minimum color rendering index level, which is the indirect efficiency level. And this was from 2009, so they're going to go back again in the next year or so and make these limits more stringent. But you can find some relatively environmentally preferable lighting equipment on the state of California's contracts as a result. Specifications for compact fluorescents, minimum, you want to make sure that they're ENERGY STAR rated. And this is really important because ENERGY STAR has a lot of different criteria in them packed into that one standard. It assures high efficiency, it assures performance, it assures that it isn't going to just quickly lose its lumens over time. So that's really important. And what I've learned for this is in the bidding process that it's really critical to make sure that that piece of equipment is actually on the ENERGY STAR list. So some of them will be disqualified because ENERGY STAR does actually go out and test compact fluorescents, and sometimes they disqualify it, and they will report. So you'll see some of these actually have a no, ENERGY STAR, no. And so you want to make sure that what the vendors are giving you isn't one that's been disqualified, because they're probably trying to unload those at pennies to the dollar. You can set a higher rated life than the minimum for ENERGY STAR. ENERGY STAR is, depending on the type, either 6,000 or 8,000 hours, but most of them are 10 to 15,000 hours in the rated life. And so you want to make sure that you're getting the higher rated life compact fluorescents, and then require recycling by the vendor. There's another really interesting thing that's happening. This is called the Top 10 EU for the European Union. We have a similar program, but it hasn't been used yet for compact fluorescents. It has been used for other ENERGY STAR, things called ENERGY STAR Most Efficient. And what they're doing is they're actually rating within the ENERGY STAR the top 10 most efficient types of lamps, literally the top 10 bulbs. And so it's a running race to the top. Companies really trying to get their stuff to be on this top 10 list, and some government agencies are using that top 10 list to make their purchasing decisions. You can find green lighting products on state contract. As I showed you the specifications, that you go to the Buying Green website, and there's information about that contract, including their specifications. There's also green lighting equipment available on cooperative contracts that are developed by other states and multi-state entities. One's called the WSCA, the Western States Contracting Alliance. They have contracts with Grainger and with some other companies that have various different types of hardware supplies. I will say, although we have a partnership with WSCA, they have not yet put the green specifications into their lighting contracts. So they do have some LEDs and they do have some compact fluorescents, but they haven't yet gone and they have other types of high efficiency fluorescents, but they haven't gotten rid of some of the stuff that wouldn't meet certain standards. So you have to be selective and know what you're looking for on those contracts. Same thing, there's a local government contract. Come on, there we go. Through U.S. Communities, also has some lighting equipment as well. So this is a case study I was talking to you about with Alameda County. And Alameda County, they did a 52-building indoor lighting retrofit in 2009, and they documented the following benefits: 30% less energy, saving 3 million kilowatts, and $350,000 per year. Their lamps last 6,000 hours longer. And as I mentioned, they went from standard grade T8s to high efficiency T8s. And they got all of these benefits. Reduced the labor costs in maintaining the building, although they weren't able to quantify that. And they eliminated 350,000 milligrams of mercury by specifying low mercury lamps. And this was actually an EPA-funded project that we did with them a couple of years ago. But you can find all of their technical specifications and a description of this case study on the Alameda County website. There's a lot of retrofits going on now, looking at the very old lighting equipment that's in schools in particular, because they're finding PCBs at relatively high levels from the older ballasts that were put in sometimes as far back as the 1960s and 70s. And New York City is committing to redoing all of its lighting, not just because of the efficiency, but also to get rid of these PCBs that are in the school that are very toxic and persistent in the environment. And here's an article that talks about that. LEDs, you guys' favorite topic. It's really great. LEDs are amazing because they get rid of many of the problems that have been associated with fluorescence. And it doesn't mean they're not completely without problems, but they are mercury-free, they are longer lasting, and their efficiency is rising, their price is dropping. So here are some of the uses of LEDs. And so exit and business signs, traffic signals, street and parking lights, lights being used quite a lot now, night lights and pathway lighting, elevator lights, so just those small lights you can get, and those are often incandescent, so you can get a good savings there. Track lighting, task lighting. Now they're becoming replacements for CFLs, or again, roughly equivalent, but they last longer and no mercury. And specialty lighting, holiday lighting. So there's lots of more applications, and we're just watching them as the technology continues to improve. There now are ENERGY STAR rated LED screw-in lamps that can be a direct replacement for incandescents, halogens, or compact fluorescents. So they're 75% less energy than an incandescent. They have a longer life, 15 times more longer life than an incandescent, and at about an average of 25,000 hour rated life. This is what they look like. They're quite heavy. And this, I think, I bought before the ENERGY STAR system came out, so it doesn't have an ENERGY STAR. But interestingly, it does have a RoHS compliant, so it doesn't have lead in it in the solder. So we're starting to see more of that. Mercury-free, they're always mercury-free. There's never mercury in an LED. And so they're a replacement for those. And there's a qualified list. So again, if you go out to bid, you want to make sure, because there's a lot of difference in quality with LED screw-in lights, you want to make sure it's on that qualified list, and it will give you a list of the actual model numbers that are qualified under ENERGY STAR, and it keeps getting updated literally by the week. The street lighting applications are broad. They can be everything from, streets, some highways. Some of them are starting to be able to be meeting the specifications for the Department of Transportation for quick, fast highways. But they're used more in parking lots, garages, beaches, pedestrian walkways. They're just typical city streets, are very typical, and then other applications. Their cost is going down. So I think the most important thing is that their cost is dropping about 20% per year, according to the U.S. Department of Energy. And they have a cost savings on a life cycle basis. So when we look at all the different costs, they have a high upfront cost. There's no doubt their cost upfront is very high. But you get 35 to 75% savings, more with the dimming. So if you have a parking lot, for example, and there was a good case study of this, at night there's nobody in the parking lot. the supermarket or whatever is closed. Why would people go in there? You don't need to have those lights on full blast. So they have what's called bi-level lighting. So it's at a very low level, and then when someone drives in, boom, it goes on. Or as the sun is coming up or going down, you can dim them appropriately. And so you can really do a lot with them more and be able to shave off energy savings from there. They last 2 to 4 times longer than traditional street lights. There's no mercury, and you can power them with solar and wind. So if you have a very remote location, you don't have to run a wire all the way out there, and that can be good for parks. The pros, very good night visibility. When they put and do demonstrations, and I don't know if they did this in your community, they often will survey the community and say, how did you like this? And compared to traditional lighting, people say they feel safer, they say that they can see better. So there's strong community approval. There's no instant restrike, which means it doesn't, if it goes out, it doesn't take more time to go back on. They're programmable. Again, no mercury, no UV radiation, less light pollution, so you can get the light right where you want it. You're not having light going all over the place. There are Energy Star standards for this technology, which there aren't for some of the other ones, like there's no Energy Star rating for high pressure sodium or even for induction lighting. And there's a list of approved products available through the City of LA. Is testing them and coming up with products. And increasingly, we're going to see approved products on Energy Star. Typically, one of the biggest benefits that people talk about with LED lighting is that they can see better. And with traditional high-pressure sodium or low-pressure sodium lamps, they're yellow. So if there's a crime, they might, ask people, interview, what color was the car? You can't tell if it's yellow or gold or white or silver, and so you have a hard time, and people feel more secure and feel like they can see better with the LED lighting. They're being put into places, there's some low-hanging fruit like parking garages that might stay on 24 hours. Even during the day, they might have lighting on, or they can have it on low level. You're going to get a lot of savings in those applications. And there are some cities that have now committed to being an LED city and just looking for as many applications for LEDs as they can. There are some interesting applications, solar-powered LED bus shelters that they put up in King County, Washington, in the Seattle area, made people feel a lot safer. They have much more reliable lighting in the bus shelter, and it didn't use a lot of energy. And they, again, can manage it through energy software, so they can manage what's going on. If an LED lamp goes out, they will know immediately because it's monitored through the energy management system. The cons of LED streetlights: high upfront costs, particularly if you're going to add these controls. Some of the street lighting projects have been funded through stimulus money, and that's helping to bring down the costs. There can be some performance problems, but that was mostly before Energy Star came in. So now you're starting to get them to monitor the performance, not just the efficiency, but the other performance of the lighting. Sometimes there can be some glare with the lighting. There can be low or uneven light output. There can be some fading. There can be some overheating. You need a heat sink. So you'll see with these lights, they can get kind of hot. And so they need to have almost like a fan built into them. You can look at those, I guess, with the other one as well. Or you can look at the box. You'll see they have almost like a fan that gets a fan shape that gets the air in there to cool it down. But there now is this Energy Star street lighting standard that's been developed, and it is addressing a lot of these performance issues. And they've looked at various issues about how do you measure the light coming out of an LED. It's a little bit different, and so they're measuring just the usable light. It's called a fitted target efficiency level. So they're figuring out, it's not just about how much light comes out, it's how much usable light is getting to the place where you need it. Induction is another lighting technology that people are considering. It's been around for a long time. It's mature, and so some people find it more reliable. It says that it usually has a 100,000-hour rated life, but it doesn't account for the lumen depreciation. So the studies basically show you have about the same as LEDs. It's not more than LEDs. It's usually about a 60 to 70,000 rated life. It does have improved visibility over high-pressure sodium. It's more efficient than high-pressure sodium. It has less mercury than high-pressure sodium, but it still does have mercury. And some people report that it has less glare than LEDs, although some people report that it has more. You can see it's more like a round bulb, and so light is going everywhere. And so you can end up having more light pollution. It's more expensive than high-pressure sodium, has a diffuse light, and so even though a lot of light is coming out, some people that have tried to retrofit to induction lighting have found that they actually have to change the pole spacing because it doesn't give you as much light. And this actually, I believe, was a study in Palo Alto that was done by the RPI Lighting Resource Center. Less optical control, so you can't dim it down as much. Less favorable in the community surveys compared to LEDs. And it does contain mercury. There are some better high-pressure sodium if people want to stay with it. I don't want to say a lot about it, except that there's one that's called non-cycling high-pressure sodium. It's more efficient. It doesn't go on and off, so you don't have to send the workers out to try to get it. And it has about 90% less mercury. But people are really, a lot more communities are just moving to LEDs. They're just leapfrogging over these other technologies. But if you already had high-pressure sodium in some applications, you can get these low mercury, higher efficiency models. And then you want to look for dark sky approved fixtures. That just makes sure that the light isn't going out, which can be a problem in the environment. It can cause birds to not migrate to certain places where they should be. So it just certifies that there's not what's called light trespass going on. There's lots of LED resources. The most important one is the Department of Energy's Municipal Street Solid State, which is another name for LED lighting consortium, and that's cities all over the country that are joining this. It's free to join, and they're sharing information about experiences and demonstrations and new technologies, et cetera. And then RPI's Lighting Resource Center has some good technologies on LEDs. In different regions, what we're seeing is that there actually are these regional LED groups that are forming. I just spoke at one in Washington, D.C., but here's one in San Diego, where the various different municipalities are getting together that are doing LEDs, and they're sharing information about different technologies. In fact, in Kansas City, what they did is they took their stimulus money and they just did a gigantic demonstration project, and they put demonstrations in the different cities, and then people would go and look at them and see which technology they really liked, because it was too expensive for each city to try to demo all the different types of projects. So I would really strongly encourage the different jurisdictions that are here that are working on street lighting to either join the U.S. Department of Energy's Street Lighting Consortium, form your own street lighting consortium. And I do know that there's a group through the Bay Area Climate Collaborative that's trying to help collaborate on the specification and procurement of LED street lights to try to help bring the cost down. And if you're interested in that, I can connect you with those folks as well. I'm going to actually leave this to you. Why add recycling to the lamps? And talk about the lamp. Do you want to talk about that now?
My name is Donna Snaringer. I'm with the California Product Stewardship Council, and as Alicia mentioned, we've been working together on issues related to lighting since our inception in 2007, and she alluded to the challenge of mercury in many of these products and the problem that creates at the end of life. And what we really wanted to talk to you about today is the importance of thinking about what you purchase and the power that your procurement policies have in shifting the system to better products in the future and ensuring better end-of-life management of the products that are already out there. So one of the things that I wanted to highlight is California actually banned residential generated fluorescent lamps from disposal in 2006. And that was because of the mercury content and the concerns about pollution in the water and trying to manage the environment in an effective way. And along with that came a dramatic spike in the cost of managing these products at the end of life. And Los Angeles County estimates that the cost of managing compact fluorescent bulbs is about $7,200 per ton, and that compares to about $35 per ton for trash. So the cost of managing these products at their end of life is tremendous. And one of the things that we would really like to suggest as you look at your different policies for purchasing is buying the best product you can, and including take-back options in your product so that in your purchasing, so that there is a plan for the end-of-life management of these products. You are being provided with information that creates procurement policies you can adopt in your local government, some sample policy language that can be placed in, and as Alicia mentioned, their information also contains a good deal of data about why this is important and why it helps. And we are really committed to the idea with many products, not just lamps, that there is a role for the manufacturer and producer in the end-of-life management of the product, and that by requiring that in your purchasing, you can really make a difference toward engaging them in the end-of-life management. So we thank you for taking some consideration of this as you look at lighting. It's a small component of it, but it does make a big difference to your local government. And we're happy to provide additional information. We have a lot of information and resources on our website at www.calpsc.org.
And there is some language, as she mentioned, that can tell you how to incorporate recycling into your contracts. And I'll just say that in both the San Francisco and the state of California contracts that I worked on, we required the vendor to offer recycling. And what we found is it actually offered the community and the state better pricing than when they had just gone out separately and tried to set up a lamp recycling contract. So you can try that, because I think the companies, the vendors, will sharpen their pencils if they think, oh, if I, offer a good price on recycling, it's going to help me win this lamps contract. And that creates an infrastructure for recycling. And probably the most important thing is that the industry says the more that they're required to actually have to pay for and set up recycling systems for compact fluorescents and other fluorescent lighting that contain mercury, it's really spurring them to want to get into LEDs faster. And so the more pressure we put on them and say, well, if you make something that has mercury, you're going to have to pay for recycling it, they're really going to speed up their R&D on the LEDs and try to get into that technology so they don't have to deal with that. Let me just end by saying, with Santa Clara County, we help them develop fact sheets for green lighting products that are available, including LEDs. And so I just made copies of this, and Mary is circulating these around. So it's Energy Star rated lamps that are available through Grainger. That was just their vendor that they used. But I thought this would be useful because it shows you what the specifications are for LED lighting equipment.